You know, normally, when I would see that Kryptonite Physics has uploaded a couple of videos, I would probably look through them and make a summary video where I address some of the points or refer back to some of my old videos and things like that. But this time things were a little different, because I noticed something which deserves a different kind of video. So here we are at part 3 of his videos, Vision and Light. Now please note that I skipped videos 1 and 2, parts 1 and 2, because part 1 is just an overview video of what he wants to do. I encourage you to watch it, and part 2 is just where he goes through the basics of the inverse square law, which I have no major quarrels with the content of this video, apart from a few things that we will see later. Now, I do, however, have a couple of quarrels with what he says in this video. Most of the things, though, are correct and show a more well-prepared structure than that I did not know previously from any flat earther. So credit where it is due, Chris. You seem to have prepared quite well for these sort of videos, but you have made a couple of mistakes that I would like to point out here. I would say to set the playback speed a bit higher, because I think the overall tone is very low.
On a moonless dark night, for a human to see a light source, at least 0.0001 lux of its light must reach the eyes.
Until here, I have accepted this number because I didn't know any better. We will later see that this number is extremely wrong.
Below that, it will be invisible.
Note these citations here.
Eyes. Below that, it will be invisible.
That say, we'll talk about the citations at a later point. Note the citations here that say the human eye could detect as few as 5 to 7 photons, which corresponds to light level around 10 to the minus 4 lux. Gives the same down here from another paper, and it goes on like that. Here, different kind of papers that seem to agree with this overall statement. We will turn to all of the paper things later.
Let's move on to color. To see the color red, white light, made of all the colors of the rainbow, each with their own wavelength, hit the object. All colors are absorbed, other than red.
Most part of the other colors are absorbed. There is always a bit of yellow that is being reflected with it, and even a tiny bit of blue, but overall you're very correct. Most of the lights are absorbed, and for the way dominant part, only red is being reflected.
It's the same for any color we see.
In principle, yes.
Your eye has 3 types of cones that respond to color. A red, green.
That is correct as well. Kudos to you.
And blue cone. From the information they gather, we see over 10 million different colors. If the lux level from the object, or light source, falls below 0.01 lux, the color...
A number that at this point I have still accepted when I watch the videos. We will also later find out that this is very wrong.
Cone receptors become inactive. Rods, marked in gray, are responsible for vision at low light levels are activated. Then we only see shades of gray. Look at a red car in low light, it will be gray. This is called scotopic vision.
That is correct.
Peripheral vision. Hold your arm out to the side and wiggle your fingers. You can sense movement without looking at it directly. This is how our
That is also correct, of course.
eyes detect very faint light, below 0.00.
And now at this point here I was curious. Direct detection of a single photon by humans. And here I started to wonder, how many lux is a single photon? Can we answer that question? Of course we can. So before we do that, I would like to briefly go about the inverse square law of light, because I think now is a good time to do so. Let's say we have a light source here in the middle. It emits light if, of course, the light source can emit freely in all directions, or reflect for some reason in all direction, all of the power of the light that it had when it was emitting the light would be spread out equally on a sphere. So the same power would be spread from the sun, for example, over 4 pi r squared, r of course being the distance. So let's say we would like to know the photons per square meter at Mars's distance. We would say, well, the intensity at Mars of photons per square meter at the distance of Mars would be the initial intensity divided by 4 pi r squared, where r here would be the distance to Mars. This is how you calculate these things. Chris UK has said this in his own video, that which is completely correct, that the intensity decreases with 1 over the distance squared, which we know is the inverse square law, which is of course correct. Note that the inverse square law applies to point sources for if you're very close to a planet. So if you would like to, for example, measure the light that reaches you from Mars as you get closer to Mars' surface, and we're talking here only about a few kilometers, the inverse square law kind of doesn't work that well anymore, because you're now not dealing with a point, you're dealing with an extended source. So strictly you would need to integrate all of the points, you would need to create some kind of grid, and you would integrate the brightness coming from all of these points, which would turn bad very quickly. But that's neither here nor there. So how many, the questions that I originally asked is how many photons are in 1 lumen? First, for that we need to calculate the energy of a single photon. As we know, the energy of a photon is Planck's constant divided by its frequency. We can also say it's Planck's constant divided by the speed of light divided by the wavelength, which here is 550 nanometers in my example, giving us roughly 3.6 times 10 to the minus 19 joules per photon at 550 nanometers, which is what we will stick for the purposes of this video. So we now need to link energy to lumens. At the very, very best, there's a physical limit, is that we have 683 lumens per watt. So if all of the energy is being put out as light, 683 lumens per watt is the best we can do. Typically, things are quite a bit below that. For example, a star only is about 300 lumens per watt. But we only want a rough magnitude so that we can develop a little feeling on how good this is. So we say 683 lumens per watt. Now, watt, of course, is a unit of power, but we kind of want energy, so we just say this happens every single second. So then we have 683 lumens per joule. And 1 photon is 3.6 times 10 to the negative 19 joules. So roughly 1 photon, if you receive 1 photon, that would correspond to a brightness of about 2.5 times 10 to the minus 16 lumens. So a photon is 2.5 times 10 to the negative 16 lumens. Now, how do lux and lumen relate? This is also explained correctly in Chris's second video. 1 lux, or sometimes expressed as Lx, is equal to 1 lumen over 1 square meter. So we kind of need to assume an area. Well, we could assume the area of the human pupil. So we say 1 photon with that many lumens per square meters for a pupil at 7 millimeters diameter would give us about 6.4 times 10 to the negative 12 lux. Now, how many photons can the eye reliably see? The paper that Chris gives here makes experiments about single photon detection. While technically apparently that is possible, it's not enough for reliable detection. So not reliable in the sense that you could perceive an object permanently there from just 1 photon. The research that I have done, and that I will link in the description of this video, shows it to be somewhere in between 6 seconds every 25th of a second, because humans, you know, the human vision processes things we see in roughly a 24th of a second. So within this time frame, we need to get enough photons to perceive this thing as there. Depending on literature, I find somewhere between 6 photons per 1/25th of a second to a few hundred photons per second, right? So you notice that 1 photon here is roughly, let's say, 10 to the minus 12 lux, roughly. 10 to the minus 12. That's 0, point, and then 11 more zeros, and then a 6 in terms of lux. Remember that. So when Chris here says that the direct detection of a single photon by humans
0.01 lux
is about,
in near
let's hear it again,
faint light below 0.0001 lux.
0.0001 lux, so 10 to the minus 4 lux. We've just calculated that a single photon would be about 10 to the minus 12 lux. And I'm not the only one saying that. Just to check, I asked ChatGPT the same question in a non-leading way, where I completely misspelled. I don't know what I wanted to spell here. It should have been how. It was huck. I don't know how that could happen, but it understood me no less. How many lux would 5 to 7 photons be in the human eye? I asked for 5 to 7, precisely because this is one of the citations that he has here. And ChatGPT goes through the exact same calculations as I do and comes out with 3.2 times 10 to the minus 11 lux for 12 photons, which lines up within reason to what we have calculated roughly, right? So we're definitely at the same order of magnitude. I am like a factor of 2 off, which is not much for these kind of rough estimations. So ChatGPT and I agree here on how bright all of these things would be. Great then. So the claims that he makes about 0.001 or 0.01 lux to see anything, also to see color, are not substantiated. You might wonder now, but he has so many citations for it. I will address the citations at the end of this video.
In near darkness, our peripheral vision, rich in light-sensitive rod cells, can detect faint light and motion.
That is correct.
When we look directly at the source, it seems to vanish. That's because the center of our vision lacks these supersensitive cells. This is why we sometimes catch glimpses of faint stars or dim objects in the corner of our eye, then lose them when looking straight at them.
That has happened to me countless times as an astronomer.
3 key points to remember. 1. If the light from an object or light source falls below 0.01 lux, you will not see its color.
That is incorrect.
2. On a dark moonless night, an object or light source will not be directly visible if the light hitting your eyes falls below 0.0001 lux.
That is also incorrect for the reasons that we've just talked about.
3rd point. Only in your peripheral vision can your eyes detect light levels below 0.0001 lux.
Whilst that is also not true, it is true that in peripheral vision you can see things that are a little fainter, a little less bright than at the center of your vision. And now look at all of these lovely citations, all of these lovely sources. Now, I would now read all of them out to you, but I think by now you have quite enough of my voice, so I enlisted the help of someone else to read these things out for me, if they would kindly do so.
A study published in the Journal of the Optical Society of America found that the threshold for color vision was around 0.01 lux, and that below this level, color perception was reduced or absent due to the limitations of the human visual system. The European Union's Council Directive on the minimum requirements for the safety of installations intended for use in potentially explosive atmospheres defines the minimum light level required for color vision as 0.01 lux or black and white. A study published in the Journal of Experimental Thermal Research recommends that the threshold was around 0.01 lux, and that below 0.01 lux color perception was reduced or absent due to the limitations of the human visual system. The National Aeronautics Space and the Journal applied optics color light level required color vision and that 0.01 lux, and that which is equivalent to color perception was reduced or absent due to the limitations of the human visual system. The American International Convention of Illumination found that the minimum light level was around 0.01 lux, and that which is level of color perception was human eyes color after light foot Lamberts. This seminal study, published in the Journal of General Physiology, is often cited when discussing the limits of human vision. The researchers found that under optimal conditions, the human eye could detect as few where the eye can no longer detect light effectively, which corresponds to a light level around 0.0001 lux. This widely also neuroscience textbook discusses the limits of human conditions, including the role of rod cells in scotopic vision at the threshold of 0.0001 boundary as a practical limit.
So given the abundance of the sources, I thought that they were mostly alright, right? So at first I suspected that he did an error in his math, but when I did the same calculations, roughly, I got the same order of magnitude. Not exactly the same, for reasons that we shall go to in the next video, but within the order of magnitude. So credit where it's due, his math seems to be overly alright. So I didn't suspect the sources until I noticed something strange. This is the first source he lists. These are screenshots directly from his video. The Effects of Light Intensity on Color Perception, Journal of the Optical Society in America. Why would the Optical Society of America spell color with a U? Now that doesn't make sense to me now, does it? So I decided to look it up. Journal of the Optical Society of America, journal number 136, issue number 4, pages 1345 to, yeah, okay, so I looked this up. This is the site of the Journal of the Optical Society of America, and now first of all notice that it stops in 1983. So there is no issue 136, so I thought maybe, you know, I'm going to play devil's advocate here, maybe the 100 here is a mistake. Maybe it's journal number 36. So I went down, journal number 36 from 1946, issue number 4, which only contains pages 183 to 244. Issue 4 doesn't even have more than 738 pages. So, yeah. Could you explain that please to me, Chris? Now, then I thought, well, they split the journal up later on. Haha! So it still exists. It still exists. Okay, let's have a look. All issues? Oh, bugger me, it doesn't. There is no volume 136 again. So maybe, again, it was 36. Issue 4, oh dear, containing all the wrong pages. So I looked decidedly for the pages, right? The pages here clearly say 1345 to 1354. Maybe he got the volume wrong, the issue wrong, so it's 36 and 136. He got the issue wrong, but the pages were correct, right? Maybe. Well, if you look at the page numbers here, unfortunately they are not sorted for some reason, so you have to look through them a little. This is where the other one should start, 1345, right? So there is a paper that will start there, but unfortunately it doesn't. There is one right here that starts at 46, which has nothing to do with what Chris is talking about. So yeah. Now, so clearly, those citations aren't a thing. At least the first one. I can let you into a little secret. Do you recognize the font style? Do you recognize the white points as a bullet point, possibly? Well, they are from ChatGPT. I have been asking ChatGPT a question that was related to typesetting, and it gave me the bullet points. Not half an hour after I watched the videos by Chris UK, and then I noticed it. It's the ChatGPT font. So all of these first 12 citations that are in square brackets, all of these that Craig has so nicely read out for me, are made up by ChatGPT. And I will go on to prove this. Second citation, European Union, Council Directive. This is a set Council Directive number. If we look at the Council Directive number, this is the Council Directive number. And this is about the member states relating to protective systems intended for use for potentially explosive atmospheres. So he got the ChatGPT got the potential explosive atmospheres correct. But let's say if it says anything, well, first of all, color. Why would you spell color with a U if you're not from the UK? 0.01 lux. Let's have a look at that, shall we? Let's have a look. Let's say 0.01. Oh dear, doesn't exist. Well, maybe they used a different comma. Oh dear, doesn't exist. Well, but surely they talk about lux, right? Oh dear, well, that doesn't exist. Well, maybe they talk about lumen. Oh, damn, that doesn't exist. But you can search in this PDF. If I select off, I get more than 100, more than 1,000 things. So clearly, nothing of that is in there. Even the word light doesn't appear, and neither color spelled like this or color spelled in the British way appear in this very directive that he's given us, which is this one. 2014-34. 2014-34. Citation is wrong. Doesn't exist. Next one. We have this thing here. Ophthalmology and Physiological Optics 38.5, pages 531 to 542. Let's have a look. Well, we have 38, issue 5, 38, issue 5, 531. So, 531, oh dear, no article starts at 531, and all of these things here are not related to how many lux a human can see. So, that's completely wrong. Next set of sources. The National Institute for Occupational Safety and Healthy. Safety and healthy. Health. Oh my god, I'm so sorry. So here I put doesn't exist with a question mark because I looked at that verbatim, what it says here, and I can't find anything. Neither can I find anything when I look for it in Lux. I encourage the viewer to look it up themselves and correct me should I be wrong. But other than that, the exact citation Chris gives does not exist, so I can dismiss it. 5. Vision Research, volume 167. Well, if I take a look, you can already see it down here. It doesn't have more than 100 pages. Vision Research, volume 167, only has pages 1 to 100. You can also check yourself. You see, nothing else is going on. Great so far. Next thing, we have experimental brain research. This issue right here, I'm not going to read it out now every time. Well, if I have a look, we have volume 237, issue 1. Well, that's annoying. That actually didn't happen yesterday when I looked them up. I do apologize profoundly. Maybe something is wrong with that website. Maybe it didn't exist when I looked at it yesterday. Apparently they have server problems. I cannot get through to their homepage. I do apologize profoundly. I encourage the viewer again to also look this up. Experimental brain research. You won't find it. I wrote in my notes here. The article doesn't exist. The page numbers don't line up. Next set of citations. NASA apparently has made statements about low light vision. Also, do you notice a pattern here? They spell color with a U. NASA, the American Space Administration Agency, spells color with a U. I find that highly unlikely. Now, I did find a low light presentation, which is the only thing that comes close. They talk about the inverse squalor, they talk about lux. all of that lovely thing. Again, when I look for 0.01, it returns no results, and if I put a comma here and not a dot, it returns no results. Now there are a couple of results for lux, given that this is a presentation about light. But yeah, 1 lux is 1 lumen per square meter. Well, we already knew that. It just tells you, yeah, I need to be able to order to see in order to perform tasks. It gives a couple of recommended light levels, but not a minimum light level, which is something that we need for a star, so or for a planet. So this neither confirms nor denies it. So it's not a proper citation. We have the American Academy of Ophthalmology, low light vision. I found nothing with that name. I did indeed look further. Nothing lines up with that precise name, low light vision. They have something about damaged eyes, where you can only receive lower light and things like that. Nowhere do they talk about color. Nowhere do they talk about 0.01 lux in combination with color. And again, they spell color with a U, which I find unlikely for the American Academy of Ophthalmology. Next one. Applied optics. The page numbers don't line up. Now, again, so here we have volume 57, issue 15, volume 57, issue 15, and when you look at the page numbers, we have here 3,843 should be the start. Now let's 3,843. Oh dear, no article starts at that. Let us actually have a closer look. Well, doesn't seem up to there don't seem to be any pages that start lower than this one right here. Unsurprising, given that that journal ranges from these pages. So I thought maybe he got the issue number wrong. I looked at issue 14, and there it should be 3,843. Remember that. So first of all, the article is split because it should end at 55, which it obviously doesn't, because at 53 another article starts. So yeah, I could just dismiss it from here. Yeah, there we go. It should start at 43. It doesn't. There is another article in the way. So again, citation doesn't count. It's made up. This wasn't citation number 9. Now, citation number 10, the International Association of Lighting Designers. I had a look. They show, when it comes to color vision, I had a couple of looks. For all of these things here, and I couldn't really find anything much other than some restrictions on how bright something can be and some minimum requirements. None of which talk about lux. None of which talk about anything related to seeing color at minimum light. They all talk about, well, you need at least, I think it was like 20 or 25 lux in low light environments for someone to be reliably able to see a step so they don't trip over it, right? So things like that. And again, color with a U. Now, given that this is an international association, I could let that slide. Next one, the American National Standards Institute. You already know how this works, kind of. Color, again, written here with a U, which I find unlikely. I have another thing here. When you look at it, there is nothing with the exact name that he gives here. We already did 4. I apologize. I should maybe close the others. The recommended practice for photometry and calorimetry for lighting displays. I put all of that in. I couldn't find anything. They give office spaces, they give indoor lighting standards, they give something about the UV and things like that. I looked at some of the adjacent topics and I could not find anywhere they specify a minimum lux for human vision. And again, I would advise the viewer to have a look for themselves. 12, the International Commission on Illumination, calorimetry. This is a CEAE number, sorry, English. This is a CE number. When you have a look, this doesn't exist. I tried looking for it on the CIE website itself. Couldn't find anything. I took a look at Google, couldn't find anything with that exact title. Again, if you find something, let me know. Other than that, it doesn't exist. And the last thing, the effects of lighting level on color perception, the Journal of Vision. The last thing here, 13. We have here Volume 4, Issue 8, Volume 4, Issue 8. We have pages 734 to 744. Now we can already guess what has happened. Unfortunately, they don't give the page numbers down here, which I find extremely annoying. But if you look at Brainard, we actually find something with Brainard. This has something to do with color detection and appearance, which is something completely different. If you look at what they say here, I had a look. You cannot see anything that has anything related with a minimum detection threshold for colors. And if you read through the abstract, it has nothing really to do with what we are talking about here. Furthermore, if we look at the thing here again, Brainard and Kerr, the effects of light level. So let me just search that. Effects of light level. Again, the effects of light level. Effects of light level doesn't return any finds, and we have here we have no one here named Kerr. We only have Curie. So the citation does not exist. Now, these are the first 13 citations, the one with square brackets. None of the square bracketed ones exist. And I would like to emphasize this. He gives 17 citations. He gives more in the form of flash-ins for some reason, which I will talk about. But the citations that he gives at the end of video 3, I believe it was, the first 13 are made up by ChatGPT. He did not bother to check. This is the standard of evidence that Chris UK employs. Asking ChatGPT for citations, which it doesn't give properly. Made the experience myself. I tested it out of curiosity, and it doesn't give proper citations. It makes up some of the names, it makes up the titles, and usually gets the journal right. So it usually picks a journal that exists. It usually picks volume and issues that exist. But still, this doesn't help anyone do anything. Great. We got these ones out of the way. Now the next reference here we have Hecht, Schler and Perrine from 1942, quite an old paper, Energy, Quanta and Vision, and would you believe it, it actually exists. I have it right here. It actually exists. I read through the article, and the interesting thing here they give is, and I will use this later against Chris, as a matter of fact, direct measurements, the minimum energy required for threshold vision under optimal physiological condition, values between, which corresponds to between this many photons and this many photons. They say quanta here. By quanta of light, they mean photons of blue-green light, which is the 550 nanometers is the more or less the optimal range for human vision, where you can see the most, kind of. This is what they mean by blue-green light. And this goes on like that. Nowhere here does it mention a lux number, but it does give a number of photons. Now, interestingly enough, according to Chris UK, somehow many photons are a given number of lux. He says that actually in the citation here. The human eye could detect as few as 5 to 7 photons, which corresponds to a light level of around 0.001 lux. Now, the last thing here, which corresponds to light level, is made up. That's not true, and they say it nowhere here. And I have already, in the video previously calculated how many lux one photon is, and you will notice that he's off by several orders of magnitude, about 10 orders of magnitude here. So this is completely wrong, and I will use this very thing here, where he says that from his own citation, and this is the one part that actually exists, that actually is true, against him in the planets and stars video, because I've done all the calculations, and all of his calculations here are, well, technically not completely wrong, give the wrong conclusion. Next thing, the international standards thing, I have already looked at that. We talked about this. I looked at this specific article here. I tried to look for this kind of CIE number here. I can't access it, unfortunately, because this is behind an institution protection, and the university that I still am with doesn't have institutional access. I did look for the title, and it is somewhat differently. Yeah, I would encourage you to look it up. I couldn't access it, as far as I can tell, and judging from the overall trends that we have so far, I would highly expect it not to list any number. Good. Let's move on. Now, number 3. The vision of radiant energy. This paper exists. I don't have access to it, unfortunately. Now, there's no abstract available, and I can't access it in any form of PDF. I went to other websites where I was hoping to find it. Oh, where would you look at that? Average vision threshold detected at laboratory is that many lux. They don't say lux, they say LX. So almost as if the things that he says aren't true. Well, would you look at that? Interesting. I didn't plan this out, by the way. And the last thing is Principles of Neuroscience, which is a neurology textbook, which I don't have access to yet again. It's a neurology textbook. I googled the name with lux, and I couldn't find anything. So apparently this neurology textbook does not contain lux or lumen or anything like that at any place in their thing. And I would be somewhat surprised, as neural science isn't really pertaining to eyes, although some would argue that there is a connection there, but no less. So what can we say? 13 don't exist. 2 out of the 17 I can't really tell because I don't have access. I would expect them not to yield anything useful. And 2 out of the 17 agree with the photons that he listed within reasonable deviation, that's fine, but disagree with the lux, and the one paper that I found here, and I will look for so many more, completely disagrees. Look at that. Chris, look at that. I want you to look at this, and I want you to ask yourself, how come that you didn't look at your first 13 citations when ChatGPT gave them to you? Not only that, I would also ask any other flat earther that commented under his video about like, oh, you're showing them with their own maths and things like that. Did you look at this 13 citations or at any of the other ones to confirm what he said, or are you just gullible? I will leave the answer to this question up to you. That leaves us nicely at the summary to part 1, vision and sources. So, brief summary on the vision part. Chris's claim is that you can't see more than 0.0001 lux, so 10 to the negative 4 lux. This is completely wrong, as we have calculated ourselves. Chris also claims indirectly via his sources that many lux are 5 to 7 photons. We have also calculated this to be completely wrong. The reality is that one photon is about 6.4 times 10 to the negative 12 lux. Thus, Chris's whole premise for all of his videos is completely wrong. At that point, you don't even have to watch the other videos. Of course, we will either way, and I will talk greatly about them. But either way, at this point, you wouldn't even have to watch the videos, as the whole premise is completely wrong. I also go on to show some sources that humans can see a couple of few hundred photons every second. Those would be in the description of this video. This is between 10 to the minus 10 to a couple of 10 to the minus 9 lux, which you can see the description for. Also, I would like to use Chris's own citations against him, as if his lux count is wrong and ours is correct, which I think is fair to say, then of course we can see a lot lower lux than what Chris is claiming in his videos. Now, this is just on the factual part. In terms of citations, it's a lot worse. It is absolutely catastrophic, I want to say. Chris's citations, 13 out of the 17, are made up by ChatGPT. You can see that by the fact that ChatGPT takes authors that are usually associated with the subject and mixes their names up a little bit, particularly the first names. They get the journal right, they get the volume wrong, they get the issue number wrong, and they get the page number wrong, which I have shown extensively over the course of this video. This happened a couple of times. Or they don't agree with him at all in terms of the lux. The rest, to me at least, remains unclear. So this is why I would ask you, Chris, have you bothered to check? 76% of your citations are made up. If you have checked that, and you decided to leave it in anyway, you're just a liar and even a deceiver. This would be horrible. I hope you didn't. I hope you said no. But then you still have an extremely poor standard of evidence. Chris, look very much forward to part 2 of my videos. With that said, I think we have enough. I thank Ella again for doing the voiceover. I would also like to say thank you very much for watching, and if you liked it, maybe you could consider subscribing. If you liked it a lot, maybe consider subscribing harder, and I will see you in the next video. Until then, good day.